In inferential statistics, when working with the standard deviation or the variance, they follow what's called the chi-square distribution. So the sampling distribution of the standard deviation or the variance, we need to go to chi-square. Now, there's often times where we need to find the critical values for the chi-square distribution in applications of doing inferential statistics, like the confidence interval for a variance, confidence interval for a standard deviation, hypothesis testing for a variance, or hypothesis testing for a standard deviation. Now, there's a lot of software packages that do allow us to do that work in the calculator options, but there are often times where we're not close to or have access to the software packages that will help us with this, and we can find these values from a table of the chi-square distribution and then just use the formulas for finding the confidence interval or for the hypothesis test. This video we're going to look at how you find those critical values for the chi-square distribution in the applications of finding confidence intervals for variance or standard deviation or hypothesis testing with variance or standard deviation. So first off, with the chi-square distribution with the table organization. Most table organizations of the chi-square distribution have the column headings that are area to the right of the critical value. So when we look at these headings, that would be from critical value right is your area. And so the critical values that on that number line, the horizontal axis where you're placing it, the number line, the numbers to the left are smaller and the numbers to the right are larger, like on any other number line. Since the headings are the area to the right, the critical values that actually are left on that number line are going to be in this left region of the table, and the critical values that are on the right on the number line are going to be in this right region of the table. Now, the table has many more headings than this one does, but I've just given abbreviated few headings for us to do the examples for the demonstration. Now, the other thing is the chi-square distribution has degrees of freedom. And depending on what application you're doing, you follow the designation for what your degrees of freedom formula is. For the confidence interval for the variance or standard deviation sampling from one group, or the hypothesis testing for variance or standard deviation sampling from one group, our degrees of freedom is n-1. So we have a column of degrees of freedom. Now again, there's many more values along in this degrees of freedom, and that's what this ... means. It's just that I've abbreviated a few of them for the demonstration for this video. So let's start by doing critical values only, so just the stage where you find the critical values for a confidence interval. So it says find the critical values chi-squared sub lower or left and chi-squared sub upper. Some authors actually subscript the upper one with the subscript of r for right. So chi-squared sub r and chi-squared sub u mean the same thing. With n equal 21, that corresponds to a degree of confidence, so we're looking at confidence intervals of 99%. Now the chi-square distribution is skewed. So another thing we have to be careful about is not only is the chi-square distribution skewed, I don't have the symmetry like I have in the standard normal curve and the student's t-distribution, but also the chi-square distribution, all the critical values are greater than 0. So you won't ever have any critical values for chi-square distribution that are negative either. Now, when it's a degree of confidence, then that 0.99 is in the middle, and I need to find out how much area is in these tails so I know which heading to look under and across my degrees of freedom to get the critical values that are on this horizontal axis. Now, the entire area is 1, so when we take 1 and subtract the 0.99, we get 0.01. And now we need to divide that 0.01 in half for the amount that's in each tail. So 0.01 divided by 2 is 0.005. So I have a 0.005 area there and a 0.005 area there. Now, my n in this problem is 21, so my degrees of freedom is 21 minus 1, which is 20. So let's first look at the chi-squared sub upper, or right. Here's the cutoff. The area right of that is the 0.005. So we're going to look under the heading of 0.005 and across from 20. So across from 20, under 0.005, it's 39.997. For the chi-squared left, the smaller one, area right of that is the 0.99 plus the 0.005. So I'm going to look under the heading that says 0.995. The other way you could think about that is 1 subtract 0.005 is still 0.995. So we're going to look under 0.995 across from 20, and we get 7.434. So then those would be the values that you place in the appropriate spots within the rest of the formula for confidence interval for your variance. And then if you were asked to do confidence interval for standard deviation, you just take the square root of the numbers you got for the confidence interval for the variance. Okay, next up, let's look at the hypothesis testing situations. So this first one shows sigma equal 2.71 and sigma is less than 2.71. It's very, very important to look at this symbol when you're looking at the hypothesis test to decide what your critical values are or what options you need to do if you had the software package. For the standard deviation, which is sigma, or the variance, which is sigma squared, you go to the chi-square distribution. If your symbols for your parameter were mu, so you have your mu is equal to, or mu is less than, or greater than, or not equal to, then you go to the student's t distribution. If your parameter is p for the population proportion, and you have that n times p times q is greater than or equal to 10, then you go to the z, or the standard normal distribution. Okay, so this though is sigma, so that's the standard deviation. So we're going to get our critical value from the chi-square table. We're going to first sketch the curve, and remember it's skewed. Remember, 0 is the smallest it can be, and it actually is greater than 0. Okay, now look at your alternate hypothesis. That alternate hypothesis is less than. Is less than is a left tail test. And in a left tail test, all the alpha goes in that left tail. All right, now, but it's a chi-square distribution, and chi-square table headings are your area right. So if 0.01 is left, then 1 minus 0.01 or 0.99 is right. So I'm going to look underneath the 0.99, and my degrees of freedom is n minus 1, so 31 minus 1 is 30. I'm going to look underneath the 0.99 and across from 30. So across from 30 and then underneath the 0.99, and I get 14.953. And that's my critical value for it. Okay, now with the variance, I don't do anything different with the values from the table. I still do the work with the chi-square distribution to get my critical values. The comparison of the test statistic, that is where you get what you need to get for your test statistic with these values. So here, I have my chi-square distribution. It is not equal to in the alternate hypothesis, so it's a two-tailed test. And in two-tailed test, your alpha has to be shared between the tails. So this tail is a 0.005, and this tail is also a 0.005. So they're going to be two different numbers I have to have as critical values, and they're not going to be opposites of each other because this is the chi-square distribution. I don't have symmetry, and all of the values are positive, I have to look them up individually. So first of all, 0.005, my degrees of freedom is 41 subtract 1 or 40. So I'm going to look across from 40 and underneath the 0.005. And I get 66.766. And now for the one on the left, remember 0.005 is left of the critical value, but the table is area right. 1 minus 0.005 is 0.995. So I'm going to look underneath the 0.995 and I'm going to look across from 40 for my degrees of freedom. So that's 20.707. And then lastly, hypothesis test for the variance. My alternate is greater than, so the area is in the right tail. It's a right tail test. My degrees of freedom, 22 subtract 1 is 21. So I'm going to look across from 21 and underneath the 0.01 because it's right tail and that table is organized by area right. So across from 21, underneath the 0.01, we get 38.932. So that's how you find your critical values for your standard deviation or your variance inferential statistics sampling from one group when you're looking at either finding them for calculating the confidence intervals or by doing your hypothesis tests. There are operations on graphing calculators that you can find this for some, depending on the model of your graphing calculator and the level of the software updates that have been done, and other software packages. But if those aren't readily available, then knowing how to read the table is definitely beneficial.